mainly lightweight. Why it is having a lightweight means its size is very small. It is the most electropositive element in the periodic table, right? Yes? Most electropositive means what will be its nature? Easily releases the electron. Easily releases the electron. Electronegativity means it has the tendency to attract the electrons. That is fluorine, right? This is most electropositive, lightweight. The element size itself is small. Okay, that is because of this properties. Lithium ion battery is having high charge density. It is having high charge density. A very unique characteristics of this lithium ion battery is high charge density. It has a capacity of 3 to 4.2 volt per cell. 3 to 4.2 volt per cell. We have studied that lead acid battery is having only 2 volt per cell. Right? I think you can remember. Okay? But lithium ion battery is having a capacity of 3 to 4.2 volt per cell. If you take an anode and a cathode of lithium ion battery, you can derive 3 to 4.2 volts per cell. Okay? How this can be constructed? In lithium ion battery, we are having graphite as anode. Lithiated graphite. Lithiated graphite means, suppose let us assume the graphite structure will be like this. Yes? Graphite, electrode of carbon, right? Yes? If you assume that this is the structure of graphite, the lithium will be present in the lattices, somewhere like this. Okay? Just for information I am giving. Okay? This will be the graphite layer, and in between at the center, then and there at regular intervals, lithium will be present. This is called as lithiated graphite. This acts as an anode. What will happen at anode? Oxidation. As usual, oxidation will happen. Coming to the cathode. Cathode will be made up of lithium metal oxides. Lithiated metal oxides. Here this metal refers to the transition elements. That metal refers to the transition, nickel, iron, manganese, etc. Is that clear? Those transition elements will be incorporated or mixed with the lithium. This is somewhat called as mixed metal oxides. Mixed metal oxides. You can have not only the manganese only with lithium, you can have in a combination of lithium cobalt, manganese, nickel, oxides also. Okay? Like this, you can have some combination also. This is another way in which you can have mixed metal oxides. This also can be used as a cathode. Okay? The purpose of having this is to make reduction reaction to happen. That we'll discuss about what is happening. What is the electrolyte means? This is lithium, phosphorus, fluoride, some form of fluoride. Okay, some form of fluoride. Okay, this is important in the current research or current trend. Lithium ion batteries are trending to make use of this as electrolyte because it is having more advantages than the other electrolyte. Is that clear? Usually, conventionally, they will make use of the lithium salt in alkyl carbonate solution. Alkyl carbonate solution. Solutions means here not it will be in the liquid state, somewhat semi-solid or some moisture-like content will be there. Is that clear? If it is the electrolyte is in liquid state means how can we make use of in our bucket and node? That cannot be possible, right? So it will be in the form of a semi-liquid or semi-solid state. Okay? So this carbonate solution, alkyl carbonate solution will act like a solvent in which the lithium salt will be dispersed. For example, some form of propylene, ethylene or something like that they will be having a carbonate solution. This is the electrolyte. Coming to the construction, I told that they will be having two chambers elements. Okay, for example, here the lithium ions will be, the anodic material will be there. What is the anodic material we have? Graphite, lithiated graphite. All these things will be kept here. LiCC. Everything will be over here. So here it will be separated by a membrane which does not allow the electrical contact between the electrode, anode and the cathode. Does not allow the electrical contact between the anode and the cathode. A very important application of this membrane which will allow it will be porous. It will be porous. For example, it will be made up of polypropylene or polyethylene, a polymer. Polypropylene or polypropylene membrane, separating membrane. Okay, it will be porous. How it will be porous? What for it should be porous? Because this membrane allows the diffusion of lithium ion from anode to cathode. This will allow the diffusion of lithium from anode to cathode. Li plus ion. Every Li plus ion will be moved from anode to cathode. What we are having in the cathode? Whatever we are having in the cathode? Li. Okay. Here also it will be in the form of layer. A 4-layered array will be there. Array is arranged. Okay. 4 layers of the components will be there. In between we will be having the electrolyte. What is the electrolyte? LiPF6 or any form of lithium salt in any carbonate, alkyl carbonate solution, an organic compound. That also helps for the movement of lithium ion from anode to cathode. Okay, what will happen at anode? What will happen at anode means here it is in the form of LiCC, right? This is anode. What will happen? They will undergo oxidation. Yes or no? Yes. How it will get oxidized? Li plus electron plus C6. That's all. This is how it will get dissociated at anode. Okay. Now this lithium plus ion will move through this porous membrane towards the cathode. What will happen to the electron? This will be negative, this will be positive. So the lithium ion moves inside the battery towards the cathode, but the electron moves in the outer circuit towards the cathode. Both lithium and electron are moving from anode to cathode. Very important. Is that clear? So the dissociated lithium ion moves from anode to cathode. The released electron will move through the outer circuit to the cathode. Is that clear? Here it is following an important mechanism. That is called as intercalation mechanism. Calation means moving and getting deposited or coated or getting fixed, tied, okay, seated in a position that is not a temporary permanent position or permanent place. For temporarily they will move from anode to cathode. The working principle of this lithium ion is by the intercalation mechanism, that is due to the movement of lithium ion between anode and cathode. That is how the electricity is being generated. During discharging from anode to cathode, the lithium ion will move. During charging, the lithium ion will move from cathode to anode. This is the working principle of the lithium ion battery. Nothing else is happening. While this happens, when the lithium ion moves from anode to cathode, electron will flow out from anode to cathode. Okay? What this is during reverse. Okay, during the reverse of the reaction, the lithium ion from the cathode will move towards the anode. Lithium ion from and cathode will move towards cathode. At that time, lithium moves through the battery, inside the battery through the membrane. Electrons will flow out from cathode to anode. All together, both lithium and electron will move in the same direction. Because of this movement, keep on the lithium ion keep on moving from anode to cathode, cathode to anode. This is called as a swing electrode. This is called as a swing electrode or swing battery. Is it clear? The lithium ion won't remain in a side. It won't remain in either anode or cathode. It will be keep on moving from here and there and here and there. But all together, because of this movement, the electrons will be produced, released, which will be collected as a electric. Is that clear? Any doubt on that? So here the lithium ion moves through the intercalation mechanism. I mentioned that it is a temporary attachment, right? How it will get attached? I told you that here we will be having lithium cobalt oxide. Lithium cobalt oxide is here. Already they will be having some crystal structure, right? Already they will be having a complex crystal structure. Because of this movement of Li plus ion, already we are having Li lithium over here. Okay. So what will happen is on cathode Li 1 minus X CO2. Okay. This Li plus C6 plus E minus. This will be in the form of, in your text it must be, it might be given as LiC6. Okay, all together they will move and form. Can you understand anything from this? This will be X. This also will be X electrons. X lithium. Can you understand anything from this? Li 1 minus X and X Li. Can you get anything? Can you understand anything from that? No? See, this space is 1 minus X means this form of lithium is present over here. Then Li 1 minus X plus Lix, what will happen? If you add these together, what you will get? 1 minus X, here X. If you add these together, what you will get? What will you get, Kanna? Minus plus cancels Li only. You will get Li only, right? So there will be a space for them there, which is a temporary. That is, it will get accommodated in that area. It will get attached to the electron, not permanently. They won't displace any lithium from the cathode. They won't get displace anything. Just they will move there, stay for some time. Okay, the space available. It won't affect the crystal structure of this compound. They won't affect the crystal structure of lithium cobalt oxide cathode what we have taken. Simply they move towards that area. Okay, they will occupy the space minus X space we have represented, right? That indicates a temporary area present in the crystal structure of lithium cobalt oxide. They will stay there. Okay, once the electron from here reaches there, this will move back. At this stage, in this stage, here cobalt is in the form of in the +4 oxidation state. It will undergo reduction and get converted into plus. So as a result, cobalt will get oxidized and lithium will get, cobalt will get reduced, lithium will get oxidized. Okay, this is what happening. But when the electron enters the cathode, again the reverse of this reaction happens. What will happen? LiCO2 plus electron you will be having, right? It will get converted into Li 1 minus X CO O2. The reaction will get reversed. That's all. will be having the aluminum foil as the current conductor. Will be having the aluminum foil as the current conductor. We cannot, that is simply, you cannot collect the current, okay, through aluminum foil. Both the ends of the anode and cathode will be coated with aluminum foil. From that, the electrical contact will be taken and the respective electric current will be collected. So here, one of the main advantage of this lithium-ion battery is it has no memory effect. Any idea about memory effect? Memory effect. Have you heard about that memory effect? See, it is being faced in all type of batteries where we are making use of lead, nickel, etc. etc. What happens means the memory effect means a very important topic is memory effect. That is, if you are not completely discharging your battery, let us assume that you can make use of till 80%, right? After that, you can charge till 80%. After that, you should not charge. Actually, condition is if you want to extend the life of your battery means you should charge till 80%. You should not drain after 20%. That is the limit. If you want to maintain the life, extend the life of your battery. Suppose if you are not discharging, your battery is still having somewhat 30%. Let us assume that, or else 40%. If you go for charging your battery without draining completely, if you go for charging the battery, what happens? The battery will think that it will get charged, it will take the current, it won't charge completely. Where it stops means from the potential only it will get charged. It won't completely charge for 80% or 90% or 100%. It will charge only up to that percentage. That is called as the memory effect. It will think that the battery will think it will. This effect of the problem has been faced with the nickel type of battery, some form of batteries. That is, the battery remember how much potential it is fed and then only charge to its lower level instead of its actual capacity. Instead of its actual capacity, it will charge from there only. That is called as memory effect. This problem has been faced with other form of batteries but not with the lithium battery. That is another that you don't search there. It is not available in your textbook. Okay, this is from out of thing. Okay, out of coverage. Next one is it is having higher charge density as I mentioned there. Okay, so it will be having, it is the most electropositive element. It has the capacity to release electrons very easily. That is why it is producing electrons. Okay, electrons will be released easily from the lithium. Hence, it can be used for collecting energy or electrical energy either in the form of a primary cell and a secondary cell. If you make lithium and manganese oxide, it can be used as a primary cell, one use battery. If you go with the mixed metal oxide, it can be used as a secondary battery. That is another advantage of this lithium-ion battery. Is it clear? And it is having one more drawback over here is you might have heard that lot of laptops and mobile phones has burnt and blasted like something while it is charging, right? The main disadvantage here is though we are separating the anode and cathode from each other, we are separating, right? During that separation, there may be a chance for this membrane to get collapsed. There may be a chance for the membrane to get collapsed. In that case, if the membrane gets collapsed, both the electrodes will come in contact with each other. Already the battery size will be compact, right? So when the electrodes touch each other, the electrons flow will be fast. They will get heated. They will get heated. Because of the heat, there may be a chance for spark. If any spark arises over there because of the heat and flow of electron, there is is a chance for they get fired. It will take place internally inside the battery. Inside the battery, if one cell gets fire, catch fire, it will spread easily to the other cell. Okay, because it is in the layered form. Okay, only polypropylene or polyethylene fiber separating layer only that can be burnt easily by the fire, and it, as soon as all the cell has been damaged completely, then only it will come out, then only it will burst out. Before you get the alert that it is being at fire, everything will blast out. Okay? Because it will happen very quietly and silently, because the cell is very compact. The battery is very compact. This is the another important drawback of this lead acid battery. Is that clear? So the lithium ion battery is working on the principle of what? Principle of intercalation mechanism. It is called as a swing battery. It works on the basis of the movement of lithium ion from anode to cathode. During discharging, what will happen? During discharging, lithium ion will move from anode to cathode. Okay, the electrons will move from anode to cathode. This will happen during discharging. During charging, what happens? Cathode to anode. The electron will flow from cathode to anode. Lithium ion will flow from cathode to anode. This is the gist of the lithium ion. Okay, what is the type of electrolyte we are using? Li3O6 or lithium solvent, any alkyl carbonate solutions. What is the anode we are making use of? Lithiated graphite, LiCC. Okay, see, during oxidation, what happens? It is getting separated into lithium ion plus C6. At that stage, this lithiated graphite will become a simple graphene sheet. It will become a simple graphene sheet because all the lithium ions has been moved towards the cathode, right? It will be freed during oxidation. During reduction, it will get back the lithium ions into their respective area. As a result, it will be retracted. The graphite, lithiated graphite will be retracted during the reduction. Is it clear? Overall,